So, next Wednesday, those corrections we do kind of in class. So I was hoping, I saw a few more people yesterday during office hours, but maybe people kind of putting that off a little bit. So if you're working on these kind of over fall break, I'll be available to respond via email. So I'll be working Monday and Tuesday. So if you have questions and you're working on those days, feel free to email me, or if you have questions today, I can kind of give you a response back. But those will be due kind of at the end of class, I guess, before we start class, either way, whenever you want to turn them in on Wednesday. Okay. Any questions before we kind of get going about that? So hopefully we're all here. Last class, I kind of heard my exploration of kind of how you should be doing those, providing kind of justification for why the answer is why the correct answer is correct, not just kind of stating the answer is C, right? Kind of giving some support there to earn those 2 points back for every question you got wrong. Okay. You'll probably also see either Monday or Tuesday. I'll put up the next homework. The due date will be kind of 2 weeks from when I post it, so they'll have a lot of time. I would start chipping away at that though as we start covering the material. So getting a start on that next week, even after fall break, kind of as we cover material, I think working on it a little bit at a time is better than kind of saving it towards the due date. And then, you're 2 weeks removed from some of the material that's some of those first few questions. Okay. So that should be kind of all the housekeeping stuff before we kind of jump into material. Any questions before we get going here today? Okay. All right. So left off last class, had this idea of Chipotle, and as they add more people, right, we can kind of think about how much is each worker adding to my total quantity, right? So another way of thinking about this, right, is really what was the change in the production or change in quantity from however many units of labor I was adding. Now here, it's a nice easy example. I'm just adding one worker at a time, right? So the difference in my quantity from the first to the second worker, well, that would be how much that second worker added. Right? So I can kind of go through each one of these and calculate what we call the marginal product of labor, right? So I'll kind of talk similar before, like marginal costs. This was the additional cost from one more unit, right? Or we're thinking about kind of the change in our total cost from whatever that change in quantity was. Now, usually we're thinking about the change in quantity was just one unit, so that denominator is usually kind of easy, right? Well, anytime we're thinking about the margin, right? The marginal fill in the blank means the additional, right? So it's the additional productivity or the additional output from one more worker now, right? And we're not looking at the units of the, we're looking at the quantity of labor here. So my marginal product of labor is kind of the change in quantity from a change in labor, right? And think about what L represents there. We kind of think about writing it out here on the board, just being labor, okay? So it's how much does my production change when I add additional workers, okay? So if I go to this one, nice and easy, because every single time the change in labor is what? When I go from 0 to 1, the change in labor was 1, 1. 1 to 2, the change in labor was add one more worker, right? So every single time it's 1 here, it makes it a little bit easier. And then it's just really, my denominator is 1. I'm really just looking at that numerator and calculate my marginal productivity of labor now. So for this first one, right, going from 0 to 1, that worker added 1,000 units. Going to 1 to 2, that worker added 800 units. All right. Going from 2 to 3 workers, that added 600, so on and so forth. Right? We can go through. Oops, there we go. And we would have, kind of all the marginal productivity of labor for each one is a bit more. Any questions on that? Pretty straightforward. Not too bad yet. So one thing you'll notice here is as I start adding more workers, right? Who did I hire first? So if I'm thinking about a firm, right? And they've got, I don't know, doesn't matter. Doesn't have to be Chipotle interviews, right? Yeah, anything. If they have their choice of any worker, which one are they going to choose first? The hardest worker, the highest quality, right? Whoever is going to produce the most, right? And you could get into a lengthy discussion. It's not just quantity, it's like a combination of quantity, quality. But the idea is we're just kind of thinking about quantity, okay? You could change that into some measure of quality and it would work the exact same way. You're really just thinking about you're getting the best worker first, then you'll hire the next best worker. So what that means is as I hire more and more workers, I'm having to move down that ladder of quality. So each worker I add adds a little bit less to my overall quantity or my overall production. Each worker I add, adding a little bit less than the previous one, right? Because I have to kind of move down this quality of worker as I hire more and more people. Now, in practice, it probably isn't going to be as stark of a difference as I have here, but I'm kind of using these values to make. So we're always going to see that we have marginal productivity of labor diminishing. Right? So as I hire more workers, the additional output that I'm going to be able to add from each worker is going down. Right? That marginal productivity of labor is going down. So if we're thinking about a production function, and we're kind of graphing this out. I think I have this on the next slide. Yeah, there we go. Right? My production function just tells me if I have this many workers or this many inputs, the workers are the only input we're interested in this example, then here is the corresponding output, right? Or production or quantity, right? Those are all kind of three names for the same thing, production, output, quantity. Right? When we write this out, we typically write it out as Q or quantity, but right, you can use those terms of production, that's what we call it production function, or you can think about it, when I say production, quantity, or output. Right? All kind of same three names for the same thing. There we go. Get that one. So between each one of these numbers of workers, you can kind of notice that the slope of this production function is really representing kind of what that marginal productivity of labor was. So the slope of my production function is getting flatter and flatter. Right? It starts out pretty steep, and then as I move up, it's getting flatter and flatter. Right? So what might a real production function look like? So we kind of think about maybe I have the number of workers here on my x-axis or labor. I've got my overall production or quantity. In practice, we're not going to have to make these like, well, we'll make these jumps of one, but we're going to see, firms could hire a very high number of workers. If I want to make this really continuous, it's going to look something like that, right? Where it starts out pretty steep and it just gets flatter as I add a higher number of workers. So you kind of think about each one of these marginal productivities of labor is just representing the slope of that production line. Okay. Any questions on that? So theoretically, I think I brought this up last class. You think about the Chipotle example. At some point, adding more people, they're just standing around, right? So I definitely don't want to hire any number of workers past the point where marginal productivity becomes less than zero, right? Because what would a negative marginal productivity of labor actually mean? That adding that worker, what would it do to it? It's decreasing my overall production. So why am I hiring that worker, right? That makes no sense to ever get past the point where marginal productivity labor is equal to zero, right? I'd be indifferent about adding that person because they don't add production or not. Now, we haven't factored in costs yet. I probably don't want to add someone whose marginal productivity labor is zero if it costs me something to employ them. But if I'm strictly just thinking about would I add this worker if they were completely cost-free, I would never add workers past that marginal productivity of zero. Okay? So we're never really thinking about this portion. That's why I kind of just drew it like that. Because we know that firms are never going to end up on that part of the production function. So this idea that we're getting diminishing returns, right, from our labor, or that the marginal productivity of labor is diminishing, right, is going to have some different or some implications for our costs as well. Right? So here, so I kind of already went through this example of employees at a restaurant, and I think I made the point last class that yes, our production function often looks something like what I have there, where the slope is starting at its steepest and then decreasing. We could have these weird scenarios where as I add workers, I could actually see my, I was going to do a review here. So, I think I said this was like just an even number. So 100, 250, and we work back down to 345, and then out of 350. So generally, the law of diminishing, we have this law of diminishing returns that the marginal productivity of labor is going to be decreasing as we add more workers. But I said it is possible if we have some specialization, which is why I like the example of like a restaurant, that you can initially see that marginal productivity of labor increases. So why is that the case? Well, if you think about it in this example, right? If I only have one worker, they're running the register and doing all the food stuff. How much did adding that first worker add to my overall production? 100 burritos or whatever my product is. What about that second worker? Well, they added 150. So that second worker allowed for the first worker to specialize in the register and the second worker to specialize kind of running the food. Right? So if we have any type of specialization, we might see this initial increase in my marginal productivity of labor, but then once that specialization, those gains from specialization go away, right? Just adding more workers, I'm getting lower and lower quality workers, and so eventually, sorry, that's not what it says. This person added 75, this person added 25. Even though we might see this initial increase, as we add additional workers, we eventually get to this point back where marginal productivity labor is diminishing because we're hiring lower and lower quality workers each time we have. But kind of mentioning that it is possible initially a really low number of workers to have this specialization effect. So let's say I wanted you to kind of do this, all right? Hopefully you're following along with me. This one should be pretty easy. And I'll kind of walk through it a little bit, but I'll give you guys a little bit of time to work on this. So let's say I gave you some goofy farmer example where you've got bushels of wheat. Right? So that's your output. And the number of bushels of wheat that you can get from each additional, from the number of workers, it's kind of shown. So if I hire one worker, I can get 19 bushels of wheat. If I hire two, I can get 36. So this column is the total quantity or the total production. So what I'm asking you for is when I add that fifth worker, what is that fifth worker's marginal productivity of labor? Right. So I'll give you a little bit of time to work on that, talk with people around you, kind of make sure that you're all kind of getting this correct. And then we'll talk about it together. Okay.
There's like that huge and this it's almost like a part of
All right. You haven't got an answer in. Take your best guess here. We got 33 of us here today. 34. All right. Close it out. All right. So how am I going to figure out what that marginal productivity of that fifth worker is? Yeah, right. So what I'm really thinking about is what was the change in quantity, right, by adding that fifth worker? Well, if I'm looking at the fifth worker, adding them, I have to go back to the fourth worker to see what productivity was before. When I had 4 workers, I was getting a total production of 64, total quantity of 64. When I hired that fifth worker, I'm getting a total production of 75. So what was the change in my quantity there? 75 minus 64 or 11. What was my change in labor? Well, I kept this one pretty nice and easy. It was going from 4 to 5 workers, so the change was 1. 11 over 1, I should get 11 there. So if I'm thinking about it, I could go through and do this for every single worker. For the first one, I can't because I can't have -1 workers. So at 0 workers, there's no marginal productivity. Adding that first worker, how much did total quantity go up by? 19. Adding that second worker, how much did total quantity go up by? Say 17 here. Next one went up by 15, 13, 11. Notice that marginal productivity is declining as I hire a higher and higher number of workers. Okay. Any questions on that before we keep moving? Yeah.
Is there ever an instance where you just kind of plateau, where you just kind of talk to people, but nothing really goes down or up?
Yeah, like I mentioned, there is a point where you would hit 0, and then adding more workers, you just don't have anything for them to do. So it shouldn't be that necessarily it's always that it becomes negative, but it definitely could hit 0 and then stay, right? I'm just hiring people and they're standing around, right? Even if I've got room for them to stand around in, they're not going to add anything into production. Yeah. In practice, no, because firms won't ever get to that point, and we'll kind of get there as to why in just a second. So there's an interesting thing about kind of the average productivity of labor and the marginal productivity of labor that we can take a look at. I may hold off on this. Well, we'll talk about the average productivity, then I might skip this again for a little bit. We might return to this next week and get a little bit of discussion of labor quotas. So if I'm talking about the marginal productivity of labor, I'm thinking about how much did each additional unit add. Sorry, if I want the average productivity of labor, all I'm doing there is I'm taking my total quantity and I'm dividing it by whatever number of workers I have. So like in this example, if I wanted to find the average productivity of labor, not how much I'm adding, I'm not doing marginal anymore. Well, for this first person, right, I had a total quantity of 19 and I had 1 worker. So 19 over 1 is 19, right? So for that first worker, you're always going to have the marginal productivity and the average productivity be the same, as long as we're looking at kind of just increments of 1. But now notice, if that second worker that I hired is a little bit less productive, what's going to be the average productivity of my workers? Well, I can think about this 2 ways. One, I can just calculate it using the formula. My total production is 36. Sorry, these don't line up quite correct, right? When I had 2 workers, my total production was 36. So 36 divided by 2 is 18. But notice, it's the average productivity of my workers. My first worker had a marginal productivity of 19. My second worker had a marginal productivity of 17. What's the average of that? 18. So this average productivity is going to give me kind of this measure of what's the average marginal productivity of my workers. Now, we don't say average marginal, but we just call it average productivity of labor. But you can kind of see that that works out there. And then for the third one, I've got 51 units. So 51 over 3. So that's going to be, so minus 3, so 17. Right? 51 divided by the total number of workers I had, 3. Each worker on average is producing 17 units. Now, some of those workers were producing more than 17. Some of them were producing less, but on average, I was getting 17 units per worker. And I continue to do this for every single quantity of labor past that point, and I can figure out what my average productivity of labor is. Okay. Now, the point I want to make here, and then kind of what this slide kind of just have a summary of is, how do I know whether or not average productivity is increasing or decreasing? So in this example, I have that marginal productivity. We don't have any specialization, right? That it's just always diminishing. So if we have no specialization and we always have this marginal productivity diminishing, what's going to be true is as I add more workers, each worker has a lower marginal productivity, right? Well, if I'm thinking about averages, if I'm taking whatever the old average was, and then I'm adding a lower quality worker with a, you know, has a has a marginal productivity lower than the previous workers I had. As I add lower and lower productivity workers, that's going to pull my average down. Right? The first two workers I had were 19, 17, right? So my average was 18. Columns don't line up. So when I add that third worker, well, their marginal productivity is lower than the current workers I have. So when I add them into the mix, that third worker is going to pull that average down, right? As I'm adding in smaller and smaller numbers, my new average is going to be smaller and smaller, right? And because we know that the law of diminishing returns, as I add more and more workers, I'm going to be adding lower and lower marginal productivity numbers, which is going to pull my average down. So when marginal productivity is less than my average productivity, as I add more workers, you'll notice here, my marginal productivity of the last worker was less than the average. So then when I add an additional worker, that just decreased my average productivity even more. Right? The idea is because if I'm adding a smaller number to my old set of numbers, so I can give you something that's a little bit more mathematical, not as much of a constant quantity. Think about it this way. If I've got, let's do, here's my original two numbers. What's the average of these two numbers? 3, right? If I add in a number that's lower than both of these, so 1, what's my new average? 7 divided by 3, so I don't know what's that going to be? 2.33 repeated, right? When I add in a smaller number, it pulls my average down. What happens if instead, so what if I add in a larger value? Well, now it's my new average. 12 divided by 3 or 4. When I add in a larger value, it's going to pull my average up. Well, when it comes to marginal productivity, I'm always adding in, the smaller values, right? So it's always going to be pulling kind of that average down. Now, that was a situation where I had no specialization. So it's pretty straightforward. If I just have the law of diminishing returns, I have no gains from specialization. I know that as I add more workers, that marginal productivity and my average productivity are always going to be decreasing. Now, the issue becomes, well, what if I have this initial kind of period where I've got gains from specialization? So don't pay attention to these numbers. I'm going to do some different numbers up here on the board. So let's say we had, I'll leave this up here. So I can do this. So let's say, maybe some quantities to think about. So we had 4, 0, 1, 2, 3, 4, 5. And I said, let's say we've got 100, 250, what did I say? 325. No, actually, I think I want 350. And just do this. So I come up with my marginal productivity of labor. We said the first person added 100 units, second person added 150, third added 100, fourth added 75, fifth added 25. Right? Just how much did quantity increase by adding each worker? Well, notice what's going to be true about my average productivity of labor when I have this specialization. Right? Well, initially, marginal productivity is increasing, right? So notice that would be like up here. Initially, as I add more workers, marginal productivity is increasing a little bit. So what happens to my average? Well, when I have one worker, total production is 100, number of workers I have is 1, the average is just 100. What about when I have 2 workers? Well, total, they're producing 250 units. There's 2 of them. So my average is 125.
So what is the marginal? What does this have to do with the average?
The marginal productivity? Yes. Right? So look at it this way. So I'm just putting them all up at the same time. Okay. But notice, so if I have one worker, right? Whatever that worker's productivity is, well, that's what my average productivity is. I only have 1. When I add in that second worker, he's more productive, he or she is more productive, right? But the first worker added in a fewer units. So the average productivity of my workers will be the average of their marginal products. Now, I don't have to do that every single time. I can simply just have the total quantity number of workers to calculate that average. But I'm kind of putting that up there so you can kind of see when I calculate this average productivity, it's really based off of the marginal productivities of each worker. So I then go through the next one. What 100 divided by 3 is? No, sorry, 300,000 is not common. 350 divided by 3 is what? 100 and oh, I made this number hard. We have what? It's 3. So I think it's 17 point something. 424 divided by 4 would be what? 106 point something, right? Doesn't matter what the actual values are. If you have a calculator, you could help me out here. But I kind of just want to use this to make a point that when marginal productivity is increasing, or notice when marginal productivity is greater than my average, right? So initially, when my marginal productivity is increasing, well, then adding each additional worker is adding a higher number to my total worker productivity, so it's going to increase the average. If the marginal productivity is increasing, then the average will also be increasing. But as soon as I get to a point where that marginal productivity is less than my average, well, now adding that worker, I'm adding a smaller number, it's going to start pulling my average down. Right? So as soon as I get to a worker where their marginal productivity is less than the average, it's going to pull that average down a little bit, which is what this signals here, right? As soon as my average productivity of labor is above my marginal productivity of labor, now adding more and more workers, I'm just adding lower quality workers, so it's going to pull my average productivity down. You can kind of see that kind of plays out here as well. As soon as my marginal productivity is less than the average, the new average is going to be lower. But initially, when I had specialization, and I had marginal productivity increasing, and marginal productivity was greater than the old average, my new average actually went up. So that's kind of the nice visual of that there. You know, if we have this initial period where we had gains in specialization, we might see that initially average productivity is increasing. But what we end up seeing in practice is that firms generally are going to be somewhere on this diminishing portion of the productivity of labor scale, right? You know, if each additional worker is adding more, I'm getting these gains to specialization, I'll keep hiring workers up until the point where they start diminishing. Those, the additional productivity starts. Any questions on this for you? I know this is kind of tough. So we're then going to kind of take this. The whole reason we have this set up is because this idea of diminishing marginal productivity tells us something about a firm's cost. So I kind of gave, I mean, I guess I kind of just told you, I gave you some reasoning behind why. But if we think about that supply curve, we thought about the supply curve represent marginal cost. As we wanted to supply and produce more units, marginal costs were increasing, right? That supply curve was kind of an upward sloping. So the whole reason why we know marginal costs are increasing is actually a result of the diminishing product of labor. So think about it this way. Back to our Chipotle example, they're adding a certain number of burritos, but now I'm going to factor in costs, right? So when I'm a firm, I don't hire more people just because they add production, right? If what they're adding isn't worth more than what I have to pay them to work, then why would I hire them, right? So we've got that. Let's assume that we're going to have to pay every worker $200, or sorry, $2,000, right? So that's their wage. I'll make it kind of nice and easy. Right? If I think about when I'm hiring workers, let's say we have no specialization. And starting out, the first worker I hired is the most productive. The next person's a little bit less, so on and so forth. But when I hire that first person, let's say they produce, actually, I think the numbers, yeah, let's say they produce 1,000 units. If I have to pay them $2,000, right? What was the kind of total cost that I had? Well, the cost of my building is always 1,000, right? So I can kind of come up with these total cost numbers. Doesn't matter if I have 0 through 5 workers, my cost of my building is always the same. But my labor costs will go up as I add each additional worker, right? If I have 0 workers, wages are $0. One worker, $2,000. Two workers, I'm paying them each $2,000, so $4,000. Three workers, paying them each $2,000, so $6,000. Right. So this kind of assumes that as I hire more workers, I'm still have to pay them kind of this constant salary. Right. It becomes more complicated when you kind of think about the labor markets where maybe I'm paying people what their actual productivity is. But for the sake of this example, we're kind of thinking about as we add each worker, we know their marginal productivity is diminishing, but we're paying them the exact same amount. Okay? Which means that for this, we look at our total costs, right? We can think about for that first worker, how much were they adding? 1,000 units. And we were paying them $2,000. You can almost think about it. We were paying like 50 cents for every burrito, right? 1,000 units, $2,000. Sorry. Yeah, each dollar spent was getting us half a burrito, right? Or each burrito was costing us $2. Two different ways of saying that. Producing 1,000 burritos, I'm paying that person $2,000. So I'm paying $2 for every burrito. Once I hire that second worker, well, they were only adding 800, right? So if they're adding 800 units and I'm still paying them now $2,000, I've actually paid a little bit more than $2 per burrito, right? So my costs are increasing as I add these lower and lower productivity workers. And we kind of think about how this is going to play out. We could then map these total costs, right, to these different quantities. So all I did here was we first basically started out today talking about the relationship between the workers and the quantity of whatever we're producing, burritos or production. Right? But from these different quantities, knowing labor costs and the cost, we can also compute total costs here. So now all I did was take the different production values, the different quantities we can get from these different number of workers, and the costs, and I put them right here. So just pull out those two columns. And what we can see is as we want to produce more, as we want to increase that quantity, well, in order to do so, we have to hire more workers. What's going to end up happening to our costs is we compute, or sorry, if we plot these points for these different quantities, we're going to see that we get this upward sloping marginal cost curve. Yeah.
Now we talked about at the very beginning, those like cost and
sunk costs, right? So
for the cost of the building, be a sunk cost at that point, because we wouldn't want to factor in the cost of the building per month.
Yeah, so we're thinking about here. It's not quite a sunk cost. We haven't got there yet, but it'll be called a fixed cost. It's a little bit different, but it's very, very simple. So you're thinking about it the right way. Right? If you want to for now, you can think of it like a sunk cost. So we've got these different costs. We can kind of plot this, right? Here's my X and Y value, and kind of see, oh, costs are increasing as I want to produce more and more, right? And it's really just a byproduct of the fact that each additional worker I hired, right? I'm getting fewer units. I'm getting a lower quantity. Right? They're adding fewer number of units, but I'm paying them the exact same. So I'm paying more for a smaller number of units. So my cost per unit kind of be increasing. Now, what we're actually going to want to do, which is kind of to your point, is not just look at our total cost values, but we're actually going to be interested in, well, what's our marginal cost, right? Well, here, right, we're just looking at the change in total cost from a change in quantity. So this is where it gets a little bit trickier than what we were doing before with workers, because for our workers, I kind of kept this nice and easy. We were adding one worker at a time. The problem is each worker doesn't add exactly one unit. Right? So when we look at the quantity values, and now when I want marginal cost, well, we said that was, I think I might even have it over there on the other side of the board. Total change in total costs for the change in quantity. But our change in quantity, unlike with labor, are not one unit. Right? So it becomes a little bit trickier. So for like this first one, we go through, right, going from 0 to 1,000 units. So my total costs go from 1,000 to 3,000. So that change would be my cost went up by 2,000. But what was the change in quantity? 0 to 1,000. So my quantity went up by 1,000. I'm kind of getting that my marginal cost there for that first 2. Then if I want to go to the next one, I think I've got it here. Yeah, so I have to write these all on the board, right? So we can compute for that first one. total cost went up by 2,000. I was adding 1,000 units or 1,000 burritos, so my marginal cost per burrito was $2. I then think about the next increase in quantity. When I hired that second worker, well, my marginal costs, right? How much would cost changing by? $2,000. But to get my marginal cost, I have to divide that by the change in quantity. Well, units aren't going up by 1 now. Here, my quantity went by 800. So 2,000 divided by 800, I get my marginal cost for that next jump will be 2.5. And then I get to kind of go through and do this for every single one. And what I end up seeing is that because I have this law of diminishing return, because I'm adding lower and lower productivity of workers, but paying them the same amount, my marginal cost as a result will be increased. Okay. Any questions on that or kind of how I was computing that? I guess I'm not writing out every single little value here. I'm saying them like, so how did I get that 2,000 subtracted 1,000, 3,000, right? Because the change in my total cost went from 1,000 to 3,000 was 2,000. Questions? All right, so set up a lot here. Generally, what we want to think about is just like the supply curve. As I want to increase quantity, as a result, my marginal costs are going to increase. And it doesn't just have to be workers, right? The reason I showed you here is, well, I'm adding lower and lower productivity workers, paying the same amount. That means that my marginal costs are going to increase. It doesn't have to be workers. It could be that I first used the most productive resources, right? And whether or not, what are the raw materials are for producing a certain product. And then as I exhaust, certain supplies, I have to kind of move to the next most productive kind of raw material, right? But workers, I think, is an easier way to think about it. But the same thing would apply if we're looking at like raw materials as well. We should see that as we want to produce more, we're going to have to kind of move down the ladder of lower and lower productivity raw materials and get this increase in marginal cost as well. Okay. So we can plot these points. You can kind of see that we get this like increase in marginal cost. For our sake, I'll always keep these examples. We're going to kind of have linear marginal cost, but when I draw it out, in practice, they're not going to be linear. So I'm just thinking about quantity, and here I'm like graphing the costs of dollars. It's kind of what's on my y-axis here. I can think about marginal cost here. We're generally going to draw it looking something like this. So why, if I just told you that marginal costs are increasing, why do I have this significant portion of that marginal cost curve? Well, we're explaining that as I add more units here, my additional costs are actually declining. Exactly, right? So the other numbers I was showing you, we had was only when we had just the diminishing returns. If we have these gains in specialization, just like the diminishing marginal productivity cause marginal costs to go up, if I actually have specialization when the marginal productivity is going up, that's going to drive my costs down.
So those marginal.
We would, well, yeah, right? When you add in, when you want to increase your production, you want your marginal costs to be as low as possible, right? You want the additional cost of providing that unit to be zero if possible. It's not possible to practice at zero, but right? You want to keep that cost relatively low. Okay. So I think here, it's not going to be too bad. It's going to be a little bit harder than what we did before. But let's say I want to know what is the marginal cost of moving between 36 and 51 bushels of wheat here. So I'm going back to kind of that farm example. I'm now giving you the different quantities and their corresponding total costs. So if I wanted you to compute marginal costs, I got an equation over there, also right here, right? How could you do that? Right, so I'll give you a little bit of time, talk to people around you, work on that about a minute or so, and then we'll kind of come back and talk about this. Hopefully, if you're following along, this one should be relatively easy.
change in the cost, the change in quantity is 15. I got
All right. If you haven't gotten an answer in, take your best guess here. Thought we had 34 before, so make sure we're getting everybody. All right. I'm going to close it out. Got people trickling in. All right. So,
How am I gonna do this one? Oh, got my equation. It's on both sides of the board here. So what's my change in total cost? It's going from 800 to 1,000, so 200. What was my change in quantity? So 200 divided by 15. Hopefully, not I see bring a calculator, use your phone calculator. We're just doing some basic math here. Should get 13.33. Okay. Any questions on that before we keep going here? Everybody got that right? So if I check, it's going to be everyone. All right. So if you have questions, let's see. Okay, so pretty close. Like I said, these shouldn't be too bad. I'm just trying to kind of make sure that we know where we're at. So we've got our marginal costs. We're going to start thinking about, given these costs, what do firms start to do? So we started off last class saying firms want to maximize profits. It's not just maximizing revenues, right? Because I can always increase revenues, but if it comes at very, very high costs, what's the point? So I've now got the cost side of things kind of understood. So we then need to kind of go to the other side, which is revenue. Okay? So you've got these increasing marginal costs. We want to think, okay, so as I add additional units, here's the additional cost. And then as I add additional units, well, what's the additional revenue that I make? Well, if we have a perfectly competitive market, which is the first market we'll start thinking about, nobody has any influence over the price. I just have to take the equilibrium price as what it is, right? If I'm selling gasoline, right, I'm a gas, whatever the kind of going price is for gasoline, right? If I start charging a price higher than that, no one's going to buy it, right? So I kind of have to charge whatever that equilibrium price is. Okay? So it might be a little bit weird to think about. If I have total revenue, it's kind of like this equilibrium price times the quantity that I sell. What's the marginal revenue or change in total revenue from a change in quantity? Okay? If every single unit I sell has to be the equilibrium price, what's the additional revenue I make from every unit I sell? So I can kind of put some numbers to maybe make this easier. So let's say the equilibrium price is, I don't know, $10, right? So my equilibrium price is 10, and I sell 1 unit. Equilibrium price is 10, I sell 2 units. Equilibrium price is 10, I sell 3 units. So this was kind of total revenue here, right? What is the marginal revenue of every single one of these? How much is it changing total revenue by? So my marginal revenue will always be whatever that equilibrium price is, right? So at least for now, we're going to talk about if we have monopoly power, things change, but for now, we kind of think about that way. So we've now kind of got this idea of we know the additional revenue that we're making from producing additional units. We know the additional cost. We need to kind of combine those two, right? So I know that when I'm adding more workers in, that marginal cost is going to be increasing. But the problem is my marginal revenue is constant, right? You can kind of think about it. If I've got my marginal cost curve over here, I could also put my marginal revenue curve. Well, if my marginal revenue is always at equilibrium price, how many units should I sell? Well, let's think about it. Break this down to 1 unit here. By selling this unit, I can make more additional revenue than the additional cost, right? So I'm adding more to my revenue than I am to my cost. My profit is going to go up, right? So tell it, I'm pretty simple, right? What about the next one? Well, my marginal revenue is still way greater than my marginal cost. So yeah, I'm going to produce a second unit as well. I'm going to continue to do that up until the point where they're exactly equal to each other. If my marginal revenue and my marginal costs are exactly the same, that'd be like saying, well, I'll make another $100 in revenue if I spend another $100 on production. So that would be a net of 0. We would kind of say like that firms are indifferent at that point, right? Adding whatever number units that is doesn't change profits at all, right? What about, so here, I was always increasing my profits. Right? So I can think about it as long as marginal revenue is greater than or equal to my marginal costs, profits will be increasing. What if a firm decides, excuse me, I'll just choose an arbitrary number, but let's say they decide to produce past this point where I said they were indifferent. Well, by producing that unit, the additional costs were way more than the additional revenue. So I'd be adding like $100 to revenue and spending $200 to do it. That would actually, anytime that I have my marginal revenue being less than marginal cost, there I would see profits actually decrease, right? So firms will never be over here, right? They're going to produce up to the point where marginal revenue is equal to marginal cost, because for every single one of these units, they were adding profits. They were increasing profits by selling more up to the point where that marginal revenue is exactly equal to marginal cost. And then past that point, we know they'll never go past that point, because if they did, they're just going to keep eating their own profits. So we end up with this rule. We can have it here. I forgot to we'll talk about this in the next slide. But we'll basically have kind of this production rule, which is how do they choose the quantity that they're going to supply to the market, or they're going to choose the quantity where that marginal revenue is exactly equal to the marginal cost. They're going to produce up to that. So that's how firms are going to choose their equilibrium. So like not the equilibrium point of the market, but their firm specific equilibrium point. How much they're going to produce. There could be like 100 firms. A gasoline example, right? One gasoline company could sell 1,000 gallons. There's however many gasoline companies, right? So the overall market quantity is much higher. But for each individual firm, this is how they'll make their production quantity decision. All right, so this should set us up pretty well. Next week, now that we have this production decision, right, we're going to actually factor that sometimes it's good to stay open, even with negative profits in regards to why. I might be able to mitigate or minimize losses. So, hopefully, you guys get those corrections all done before we leave class Wednesday. Have a fun, safe, have a fall break, and I'll see you guys back next week.